Hello everyone and welcome back. This is Mr. Kovault, and in this video I'm going to be going over orbitals. And so let's get into this. So what are orbitals? So basically orbitals are going to be where the electrons are, or where they quote unquote live. And so before we get into that, we have to start with Niels Bohr. So who is Niels Bohr? So Niels Bohr was a scientist from England in 1913. He was trying to figure out why the electrons, being negative, don't fall into the nucleus, which has positive neutrons. As we've learned, or as you probably have learned, is that the nucleus of the atom has protons in it, which are positive, and the other particle other particle in the nucleus is the neutron, which is neutral. And so since the nucleus of the atom has these positive protons in the nucleus, that would make the nucleus positive. And so if you've got these negative electrons and you've got these positive protons in the nucleus, the question is raised, why aren't these negative electrons falling into the positive nucleus? Because we know that opposites attract, opposite charges attract. And so this was a problem or a dilemma that was raised by scientists at the time. And so Niels Bohr was trying to figure out a reason or why that is. And what he came up with is the orbit. So what he said is that electrons are orbiting the nucleus like rings around Saturn, or say, or more likely, or I should say, more analogous would be the planets around the sun. So you could have the sun in the middle, and you have the planets orbiting around the sun. And so if they're orbiting, they're going around the sun, or if the electrons are going around the nucleus, then that you have this centripetal force, right? If you have the experience of twirling something, right, you feel a force on that object that you're twirling. And so if you were to let go, it would fly off in one direction, right? So there seems to be some sort of force that's driving it outwards. So if the electrons are moving around in a circle, it seems, the argument goes, that the centripetal force is kind of counteracting or counterbalancing the attractive force of the nucleus, and so the electrons are not falling into the nucleus. And so, and part of that, part of the argument was that you don't see, if electrons are farthest from the nucleus and they have a certain amount of energy, then as they get closer to the nucleus, the question was raised, well, those electrons would be losing energy, and if they're losing energy, we would see that energy and everything would be glowing. We don't see that. So that's kind of another argument, but that goes beyond this video. I'll talk about that more in another video. So that's Niels Bohr. So if you can imagine the Bohr atom, you have the center, which is your nucleus. And if you can imagine your normal picture of the solar system, right? You have the sun in the middle, and you have the different planets in their different orbits around the sun, right? So the closest planet would be the first circle around the sun, and then the next planet would be the second circle, and so on and so forth, right? So each planet has its own orbit. Of course, the orbits aren't circles; they're ellipses. But you get what I'm saying, right? So if you have in your mind's eye that picture of the solar system with the planets in their own separate orbits around the sun, that is the picture of the Bohr atom. You have the nucleus in the center, and you have rings around the nucleus. Each ring is where you have the electrons. That's where the electrons are located. And you have a different number of electrons in each ring, and we'll get into that a little bit later and in future and in other videos. Okay, so that's the Bohr model. So the Bohr model is kind of replaced by uh, or a better model or a better picture is more of the shell model, because the electrons are not traveling in orbits. It's more of like a three-dimensional picture. So you could see that the electrons are in like a shell. And again, the Bohr model with the solar system model and the shell model are not the model that we use today. These are simpler versions of the atom that we can use to explain things more simply and more easily. This is very much like how sailors today use the geocentric model. Geocentrism, or the geocentric model, is that the Earth is the center of the universe and all the planets in the sun revolve around the Earth. Of course, today we don't hold that view. We hold a Copernican view where the sun is the center. Not even that the sun is the center of the universe, but the sun is the center of our solar system and the planets go around the sun. But be that as it may, sailors today use a geocentric model in order to navigate from place to place across oceans, right? Why? Because it's just a simpler way of using or of getting from point A to point B. It's a much simpler model, and it works, right? So if it's simpler and it works, why not use it? So in the same way, the Bohr model is a simpler model, and it works in a lot of ways, and it helps explain some things, but of course, it fails in other ways. And so we go, in order to explain other things, we need to have a better model. So in this shell model, we have a three-dimensional picture of what's going on, right? So you have the nucleus in the center, which is positively charged. You have the negative electrons on the outside. They're traveling in a three-dimensional picture. So that is a shell, right? So we could think of the electrons, instead of orbits, they're in shells. So they're traveling in this shell, right? So this would be an example of hydrogen with one proton, no neutrons, and then you have one electron traveling in this shell, right? And then you have oxygen. So you could see here again, the nucleus of oxygen has neutral neutrons, and it has protons in there. It has 6 protons. And so, or at least it should have we don't see all the protons, but we have protons and neutrons in the nucleus, and you can see that the oxygen has 2 shells. He has an inner shell and it has an outer shell. So in Bohr's model, it would be orbits. You have one orbit, and then on the outer, you have an outer orbit. And you can see that the number of electrons in the orbits are different. So here you can see in the inner shell, you have 2 electrons. So 2 electrons are in that shell. But you can see in the outer shell that there are 8 electrons. 1, 2, 3, 4, 5, 6, and then, I'm sorry, 6 electrons, my bad. 6 electrons. We have a total of 8 electrons. And so that matches the atomic number of oxygen. So we have 2 electrons, and I'm sorry, we have 8 electrons and 8 protons. So that balances out. So you have a neutral atom. And then finally, in sodium, you'll notice has 3 shells. So notice that the first shell again has 2 electrons. So this has 2 and 2 in common. Oxygen and sodium both have 2 electrons in their innermost shell. That is something to keep in mind, right? So that seems to be a maximum number of shells for the innermost shell, that first shell. Also, you'll see in the second shell here that the number of electrons is 8. So you have 1, 2, 3, 4, 5, 6, 7, 8. And in the second shell here, we have 6. So it seems that this second shell can hold 8 electrons. It doesn't seem to hold more, because notice that this 1 electron in the third shell doesn't go into this second shell. It goes into a third shell. So it seems that here that the maximum number of electrons is 8. So oxygen could have 2 more electrons. And so if oxygen here added 2 more electrons to this shell, it would have a negative charge. So that would make it a +2 ion. So we've talked about ions, and we'll talk about ions again. So this indicates or explains why oxygen tends to have and has a charge of -2, because you could fit 2 more electrons into that shell. Okay. And so you can see here that this third shell for sodium has 1 electron in there. So this kind of builds up a structure, an electron structure of each of these atoms. And so they're building up in shells. And so this is a simple way to understand the structure, the electron structure, or what we'll call a little bit later is the electron configuration of atoms. But this, again, is not the best picture or the most correct picture of the atom. It's not like the electrons are traveling in shells. But in the modern model, which is the quantum mechanical model, we view them not as shells, but as clouds. And we'll get to that right now. So here is the electron cloud model. So the electrons travel around in random, electrons travel around the nucleus in what are called random orbits. That isn't even correctly stated. It's not we say that they're in random orbits. They're just traveling randomly within a certain space, right? So electrons can't even be said to be traveling in orbits. We don't know exactly how they're traveling, right? All we can say is that the electron is within a certain space with a certain amount of probability. We say, if you look at this circle around here, right, you see that circle. A lot of times you'll see this kind of density map, right? So where each dot represents a probability of where the electron is, right? So you'll notice that towards the center of this density map, it's quite dense. It's more dense towards the middle, which is where the nucleus is. And as you go farther away, it's much less denser. So the farther you get away, the lower the probability of finding an electron in that space, right? So you can instead of thinking of this as, planets orbiting the sun, you could think of this as bees around a beehive, right? So the closer you get to the beehive, the more dense the population of bees is. But as you go farther away, you're less likely to run into bees, right? So that's an analogy I think is appropriate for this model. So what does this circle here mean? It means that usually within this particular space, that has a 90% probability of finding the electron within that space. And that, ladies and gentlemen, is what we mean by an orbital, or an orbital. It's a probability cloud. It's a space in which we have a certain probability, 90%, of finding an electron. And that is the best we can say, according to the modern model. So we can't predict exactly where the electron is. We can only say with a certain amount of probability where that is. And that's the electron cloud, and that's what we mean by an orbital. Okay. So that, in a nutshell, is the modern theory. So I hope you enjoyed this video. I hope this was informative and eye-opening. And if you like this video, please smash that like button. Hit that notification bell, subscribe to my channel so you can be notified of any other videos I put out. Please put a comment in the comment section, ask me questions, let me know what you think. Thanks for joining me, and have a great day.